Hi everybody, welcome to the last podcast is usually the best talk, so I'm delighted to introduce Sanna Arpiainen from the VTT in Finland, and Sanna is senior specialist and will tell us a bit more about their graphene biosensor with monolithic CMOS readout. Sanna, over to you.
Hi, hello. I will just tell about that as soon as my are here. Good. So welcome for the last session of today. And I'm really from VTT, and I've been doing this work together with my colleague Miika Soikkeli and also others that are working with me. And the outline of this talk is that I will shortly introduce VTT, and then our integration process with Graphene on CMOS, and then our processing services that we are providing. And I hope the slides are changing, but they do it slowly. So VTT as a company is a government-owned research institute. We create sustainable growth by tackling global challenges. We are roughly 2,000 employees in Finland, and we do everything from food industry to cybersecurity, and try to like, for example, create food directly from chemistry and biochemistry, from without any poisons or without basically anything, just from carbon dioxide and water and some ingredients. And so our basic customer segments are from energy, electronics industry, biotechnology, and we are basically doing lots of cross-disciplinary research. For example, with graphene, we are doing combining kind of like a research on biotechnology with the electronics and electronics fabrication. And our team where we are from is VTT Microelectronics, and I hope these slides change. Okay. We are working with design and prototyping and pilot manufacturing of all kind of electronics and microelectronic systems. We have the largest clean room in the Nordic countries and a really large portfolio of different techniques that we are selling and licensing, and also fabricating for people. Everything from radio frequency and antenna solutions to quantum systems. We are now currently building up a quantum computer, for example, with some Finnish company IQM. And one of the topics that we are working on is graphene and 2D integration, and that relates to the topic of today, which is CMOS integration for biosensing applications. And graphene in biosensors, which is the next slide that someday is changing. So we can think of two different types of graphene in the biosensors. One is this graphene dispersions. I think most of the talks today, have been about some kind of high surface to volume fraction types of graphene. But what we are working on is CVD graphene, monolayer graphene that was also mentioned and discussed by at least Graphene today. We are aiming to quantitative high-end sensors for kind of plasmonic and optical sensors and different other types of sensors. But basically, what I'm now talking about is electronic sensors. Because we are trying to go for the construction of on-chip quantitative point-of-care assays, and we're not on the only point-of-care, also laboratory assays, but the point is that they have to be quantitative, they have to be reliable and repeatable. So basically what we need is an on-chip assay, and that means lots of referencing. We need high statistics, and that can be achieved with CMOS readout. And we also have to compensate issues like device-to-device variability and drift that is